Hi everybody, hope all of you are well. Today I will start a new chapter, the structure of atom. In class 9 already you have read this chapter, okay, you have sufficient concept of the Rutherford atomic model and Bohr's atomic model. So you know the atomic concept of matter was first given by John Dalton in the year of 1808. The inner structure of atom was first proposed by Rutherford in the year 1911 on the basis of its alpha ray scatter experiment or alpha particle scattering experiment. But you know that he was unable to explain the stability of the atomic model. Later, in the year of 1913, Niels Bohr proposed a new model of atom with the help of quantum mechanics or with the help of quantum theory of radiation proposed by Max Planck. Now today we will start from Bohr's atomic model. As you know that your syllabus is reduced, if you want to read the others, that is the discovery of electron, proton, neutron, black body radiation, photoelectric effect, that you will read from your book, okay. Now as the time is very short, so we will discuss here according to your school syllabus. Now today we will start from the Bohr's theory. Now what was the first concept or first point of the Bohr's postulates? An atom consists of a massive positively charged nucleus concentrated in a very small space. So if this is the atomic model, this one is the nucleus. And the electrons are moving, okay, around the nucleus in a certain specific path. These are called circular orbits, okay. And when these electrons are moving, they are not radiating any energy. So these non-radiating orbitals, non-radiating orbits, these non-radiating orbits are called stationary orbits, okay, or stationary states. And next point is each of the fixed circular orbits or stationary states is associated with a definite amount of energy, and each state energy is fixed or it is called quantized, okay, like the ladder, okay. Each step the energy, potential energy is fixed. Here also in each orbit the energy is fixed, and the stationary orbits or stationary states is associated with definite amount of energy. Hence the stationary states are also called energy levels. The energy associated with different energy levels increases with increase in distance from the nucleus, okay. So here we can see here in this diagram that this one is K cell, this one is L, M, N. Here if you can also tell that here N is equal to 1, N is equal to 2, N is equal to 3 and N is equal to 4, okay. So different energy levels are there. So this different energy is associated with different energy, and the energy expression is generally given by En. En is the energy of the nth number of the orbit, okay. So here derivation is not in your syllabus, so I am writing the expression, mathematical expression. So this is equal to minus 2 pi square z square, 2 pi square z square e to the power 4 m divided by n square h square. Okay, this is the energy level, okay, or energy associated with a particular orbit, nth orbit, okay. What is the Z? Here Z is the atomic number. What is E? E is the charge of electron. What is M? M is the mass of the electron, and H is called Planck constant, and N is the number of the orbit. Now different energy levels are not equally spaced. That is the energy difference between two successive energy levels is not the same. It goes on decreasing with increase in the values of it. Here we are seeing this is the energy level, this one is the energy. So this one is K cell, L cell, M cell, N cell. So the gap is continuously decreasing. Next point in the Bohr postulate we will discuss that only those orbitals are permitted for which the angular momentum, that is MBR of an electron, is whole number multiple of h by twice pi, and is given by the relation that is MBR is equal to NH by twice pi. What is MBR? MBR is the angular momentum. Okay. Now in this relation, that n may be 1 2 3 up to n. Okay. And what is h? H is Planck constant. M and v are the mass and tangential velocities respectively, and r is the radius of the Bohr orbit. So radius is the, here in case of K cell, from here to here is the radius from nucleus center to this orbit. This is called radius. Okay. Now this radius also we can derive. Okay, derivation is not required, you only try to remember this expression. The radius is generally given by Rn, and Rn is equal to n square h square divided by 4 pi square m square z. Okay. Now the velocity of electron in n orbit, that is Vn, is generally denoted by Vn is equal to, in case of hydrogen atom where we are putting Z is equal to 1, that is 2 pi square divided by Nh. Okay. So here Vn, okay, Vn is equal to 2 pi square by Nh. Okay. Next we will discuss the another point of this postulate, that the energy is emitted or absorbed discontinuously in the form of quantas or small packets only during electronic transition between two stationary states of energy E1 and E2. The frequency of the emitted or absorbed light radiation is given by E2 minus E1 is equal to h nu. Energy is absorbed during an electronic transition from a lower to higher energy level, and the energy is emitted during electronic transition from higher energy level to lower energy level. Here 1 2 diagram is there. So here this one is the K cell to L cell. So K cell to L cell means energy is increasing. So it is going from lower energy to higher energy. So energy will be absorbed. If the K cell energy is E1 and L cell energy is E2, so the energy absorbed will be E2 minus E1. And in this case, that L cell electron will going down to the E1's K cell. Okay. Here the energy will be emitted as electron is coming down from higher energy level to lower energy level. So the energy emitted will be E2 minus E1. Now an electron moving in a particular energy level without losing energy is known as the ground state, and on gaining energy from an external source, electron jumps from lower energy level to higher energy level, and this is known as the excited state of the atom. However, the excited state is unstable, so the excited state, always excited states are unstable. So at excited state, the electrons jumps back to the ground state level by losing some amount of energy in the form of light or heat, okay, of radiation of suitable wavelength. And these accounts for the spectral lines in the hydrogen spectrum and atomic spectrums of other atoms. Okay. Next we have to discuss about the spectrum. Okay. Otherwise you cannot able to understand. Now what is spectrum? All of you know, if we pass white light through a prism, what will happen? Suppose we are passing a white light through prism, then there will be formation of 7 colors. That is called deep geode. Okay, and this is called spectrum. So the splitting of a polychromatic light, polychromatic means different types of wavelength. Monochromatic means when there is only single wavelength. So sunlight consists of different wavelengths, so it is a polychromatic light. So the splitting of a polychromatic light into its constituent radiation is called dispersion, and the pattern of radiations obtained due to dispersion is called spectrum. When sunlight is passed through a prism, here I have shown you, this is the sunlight. Then what will happen? The spectrum obtained, that is a picture, is called the solar spectrum. Okay, and the spectrum consists of 7 colors band. Okay, and solar spectrum is a continuous spectrum as there is no gap between the different color of bands. So this is also, we can say, that is band spectrum. Next we will discuss the atomic spectra. Atomic spectra consist of lines, as there are gaps between the lines, and so the spectrum of atoms are not continuous, and this type of spectrum or atomic spectrums are called line spectra. Okay. So next we will discuss the classification of atomic spectrum. Atomic spectrum may be 2 types. Atomic spectra may be 2 types. One is emission spectra, another is called absorption spectra. When we are passing that the source of sunlight, okay, sunlight is passing through prism, definitely it is the emission spectra. Okay, emission spectra are produced by analyzing the radiation emitted by excited atoms. Okay, so sun is in the excited condition, and this light when passed through prism, we are passed through prism, then we will get a spectrum or band of colors. Okay, that is called emission spectrum. Such a spectrum consists of a few sharp lines separating by, in case of atoms we are discussing, in case of atom we will get lines, okay, separated by dark bands is called line spectrum. Okay, line spectrum is a fingerprint of atoms of each element, has its characteristic spectrums just as each individual has its characteristic fingerprint. Each line in the spectrum corresponds to a particular wavelength of frequency. Next we will discuss the hydrogen spectrum. The spectrum of hydrogen can be obtained by passing an electric discharge through the hydrogen gas taken in a discharge tube under the low pressure. The radiation thus obtained is analyzed with the help of a spectroscope. Okay, a series of lines are obtained in the infrared, visible and ultraviolet region. Okay, so here we have shown here the how we are getting this type of spectrum, that means hydrogen spectrum. The entire spectrum consists of lines in various regions, and they are named after their discoveries. Okay, discoverers. Okay, who have discovered. So generally this type of spectrum is obey one equation, that is called Rydberg equation. The Rydberg equation is (1 by lambda is equal to Rydberg constant, its value is 109677 centimeter inverse or 78 centimeter inverse into 1 by n1 square minus 1 by n2 square. Okay. Now what are the n1 and n2? N1 and n2 are the energy levels, and n2 is greater than always n1. Now here we have shown in this one what is n1 here. So here n1 is the 1 and n2 is maybe 2, 3, 4, 5, 6, 7. These are the higher levels energy. Okay. So in this way we are getting Lyman series. Lyman series lies in the ultraviolet region. Okay. And when the comes to the L cell, all electrons are coming from higher energy to L cell, then we are getting that Balmer series, and Balmer series lies in the visible region. Okay, So here it is coming from 3 to 2, then 4 to 2, then 5 to 2, then 6 to 2, then 7, then 8, and then Hertz. Okay, we are getting Balmer series in the visible region. Then we are getting Paschen series. Okay, in the same way in the infrared region there is bracket series in the infrared region, there is Farn series in the infrared region. Okay, so the wavelength of the spectrum lines of other series can be calculated by a general formula that I have shown. Is the lambda is the wavelength, or it is called nu bar, wave number. Okay, and this equation is called Rydberg equation. Emission spectrum of molecules, okay, is called band spectrum or molecular spectrum, and the band spectrum consists of a number of bright bands, okay, separated by dark spaces. And so we can say that atomic spectrums are called line spectrum, but molecular spectrums are called band spectrums. Next we will discuss the absorption spectrum. When a continuous electromagnetic radiation, example white light, is passed through a vapors of an element or solution of a substance, and the transmitted light is analyzed by a spectrograph, then the spectrum obtained consists of some dark spaces, okay, and these dark spaces corresponds to the light radiation absorbed by the substance. For example, when sunlight is passed through sodium chloride solution and then through prism, then two dark lines we will observe of wavelengths 5896 angstrom and 5890 angstrom appear in the spectrum, and this is known as absorption spectrum. So now we can understand the basic difference between the emission and absorption spectrum. So in emission spectrum, so suppose if we take one burner, and here we are taking that sodium salt NaCl, then this light, if we excited it, then this light, if we pass through a prism, then we get two yellow lines, okay, in the spectrum, and the wavelength of this line will be 5896 angstrom. Another will be in the 5890 angstrom. So this spectrum is called the emission spectrum. But if we take a solution of NaCl solution of NaCl, okay, that is sodium chloride solution. If we pass white light through it, then this transmitted light, if we pass through prism, okay, then what will happen? We will get two black lines. These are the bright lines, and this is the black space or lines, and in this case this is called the absorption spectrum, okay, and we get at the same wavelength, that is that 5896 angstrom and 5890 two dark lines, okay. So that means that the yellow portion of this light, okay, is absorbed by the sodium chloride solution. That is why it is called absorption spectrum. So in emission spectrum we get bright lines by analyzing the radiation emitted by an excited substances, but in absorption spectrum we get dark lines by analyzing the absorbed radiations of white light passing through the substance in vapor state or in solution, okay. So hope you can understand the difference between the absorption spectrum and emission spectrum. So today up to this, next day we will discuss the merits and demerits of the Bohr's theory, and we will practice different types of numericals based on these problems, okay. So okay, today up to this, thank you.